Welcome to section 17 of the course as persistent with C++ and Qt. Now we're going to implement the final instruction of compiler. Okay. Now the case wherein there is this is the right operand, and we have two cases that are very important. That is the ID and the operator. So as you might see, we have another switch inside it that is handling the left operator, and something I would like you to notice is that we will have the same instructions to the operator. So for instance, and for this situation, we are going to create a new function that is called viewLeft token, that is going to encapsulate everything inside everything that you can see here. Is the switch of the left token. This function is going to be const and private because it's the only one that is going to use it is this function of compilation. So we need to go to the header. As you may remember, the default scope of the class is private, rather than the struct that is public, so we don't even need to write private, or maybe it should be a good idea to put it. So it's void build left token are going to have references as parameters. You might remember that the references are kind of taking the original object and modifying and using it inside of the function. While when we are using a local static object, it means that we're creating a new object and it's not working for us in this occasion, because all the parameters that we are going to interfere here, they are going to be modified. So let's begin. Reference of int left int right proplex analyzer, and is a lexem reference. We're going to call it just operation. Next one, prof lex analyzer lexem right token. I'm pretty sure that we are not using this, so we'll just pass it to unsigned it int sign out q stack with int and builder stack q stack another stack, but this one will be from analyzer lexem elements. It's also a reference. I'm going to call it the token stack. The last one is a reference to a boolean. It's validated. Because this function is called inside of the compiler, we also need to be const. If we don't do that, the compiler will reclaim. It's void infix analyzer. Thank you, Qt ID. I really appreciate it. And let's implement it. Okay, the only thing that we need to do is to copy and paste everything from the case ID and change the names to their respective ones. We're saying that we're going to just remove the O. So it's from this port until let me just see this comes. Okay, I got it. The only difference between the ID and the operator is that we have the opportunity to create a atom node because we already have the right token, but for the operator we need the left token, so we need to delay it until we have it verified. Then let's just eliminate the else with the underscore. Because we don't have any switch of loop, we will change this to a return. And it's pretty much the same, so I will try to make it as good as possible. For example, if you have used Visual Studio, it's pretty easy to change the names of the variables. But we are not using Visual Studio, and Visual Studio is very complex compared with the Qt ID. I think that's it. Let's just do a quick compilation request and see if there is errors. Great. It's validated. Oh, of course. Viewed. I forgot to rid off of this L. And seems that everything is okay. So finally, the next step is just look for the part where we need to put everything here, and it's view left tokens. Let's do some magic. So left, L, right, L, operation, cool, L signal, L view their token. View the stack, L token stack, and L is validated. Just while we are copying it, and that's it. Pretty easy, huh? And look at this. Imagine this whole long lines of code duplicated in the compiler function is make me feel pain, because even when the compiler function is pretty large, and adding more lines of code is quite it's not that good. It's not good to clarify and make our code easy to understand. And doing it this way, we also avoid a very important topic, that is code duplication. We need to ensure that we are not duplicating the code. So this is a pretty good way to avoid it. So that's it. So the next step is continue with the sequence. Something I was forgetting is that we need to handle errors from the token loop. We're just passing from this part of the token loop to the verification rule verification part, and we don't even know if it's an error, or we might even handle the errors directly and say, well, there is an error, there is no necessity to verify it. So let's skip it and go outside of the loop. Maybe a good example of what we're going to do. For instance, this means that the for means that we reach the end of file. So if we reach the end of file, just break it. We don't have anything to verify. And the second one is the compiler process. Remember that the compiler processes the whole rule in the loop above of these sentences. push it in the builder stack and set up the flag of saying that the rule is available. It's available to join to another rule, and this is meaning that it's this part in the process, the builder stack should only have one element. Okay. So if we have more than one element, it means that we have an error. So let's handle it. L is rule available. We're saying that it's available, but the builder stack size is less than 2 because we need 2 nodes to create an operation. If so, let's signal equal to 11 and break. I just forget to put the arrays of strings. I'm going to do it to the end, so bear with me. Well, the third case, remember that the token groups, we got all the tokens of the rules because of there should be at least 2 operands to create operation in this part, of course, and the builder stack represents the rule, and we are just putting more nodes and nodes in the builder stack. And if there are less of 2 operands and there is only 1 rule, it means that there is an error. We need at least 2 operands. So we need to handle it when there is we are in the end of the file or not. It's pretty easy. Just put some file inf signal for token stack dot size is less than 2 and f builder stack is different. Oh, that size is different than 1. We need to trust me, I know what I'm doing in this part because I really have notion of the code of every row. In this case, we're saying that in this part we're saying that there are too many semicolons. We're saying that we finished it. I don't know, maybe on the sample 3 rows that we're having 3 semicolons sequentially. And we don't have enough nodes to complete the rules. So this part is for not enough, or maybe too many semicolons. And in this part, we don't have enough tokens to fit the operation. Enough tokens to fill the operation. Okay. Even in the same case, when remember the forum says that we reach the end of file. In this case, we don't have to handle it, but we need to put in another sign-up to be consistent with what we saying to the user. So the next step is signal equal 8 and break. Okay. So we also need to handle a common error that is when the user or the person who create the knowledge base put non-closed brackets. So remember that a closed bracket means that we finished a part of the rule. Remember that we can have a rule maybe A and B and C and D. So every operation needs only 2 operands. So in this case we need a closed bracket with it A and B, and after that another close bracket after the C, and another bracket, close bracket after the D. So we need just to handle it this way, and if the signal is equal to that we don't have any tokens, and I mean any not enough close brackets, then we're just going to finish it holding the signal. Okay, so returning to the binary operation, in both cases we need to build the operation before finishing the process, and to do so we determine which operation to build. Of course, we need to ensure that the rule is validated. So we're going to do this in this part called one. Okay. This is the else, and this is the switch. Okay. So I'm going to put it in this part. If L is validated, the current rule is validated, next we are able to build the operation. So more or less, if operation dot m as token, it's equal to this one. So operation dot m in 3 index equal n mptb. If L left, L right, else if operation dot m is token we don't need to that. I'm doing a operation dot m3 index equal m ptb and left, right, else if left, right. And the last, in this case, what am I doing here? Sorry. This part is not going to work. Instead of that, n as token is equal to and if any of these cases is operation, we just need to throw an error and say okay, and this rule is already not set, so the validation is false to the next rule. So now that we solved the problem, we can push it to the stacks and process to the next rule. Remember that operation might be represented as a atom for future processes with another rules. So push of operation dot m is string index, and don't forget the token stack. We're also going to push it, and directly the operation. Okay, then we will finish to verify all the rules for any signal that was thrown. There is a final checking of the match between open brackets and closing brackets, and this is mandatory to check before we determine a solution or a return value, to make sure that the rules are in the correct state. So this thing is here. I'm going to say if n open bracket or n close b, then error signal equal 9 if ln open bracket is more than the closest, then signal equal 10. Okay. Now the only way to finish correctly this compilation is to reach the end of the file, and that the tree stack has only one rule, and also finally that the token stack contains only one token representing or indicating the same identity. So if we reach the end of the file and the bigger stack size is the same to 1, and a token stack size is equal to 1, then return true. Eureka, we finish it. If there is more than one token, this state means that some rules didn't close some of the operations, so we need to handle it in a way that size near the 1, and we also reach the end of the file, then the signal will be 1. Okay. For the future stack, as we did here, we need to do something similar to the future stack, but throw in another signal. So elf builder stack dot size, it's different font, and signal is equal to 4, signal equal 3. I just forgot to put the n, meaning that it's an integer here, but doesn't matter. Okay, the final synthesis of our compilation, or may say a compile function, is saying to the, if there is an error, of course, saying to the user that signal array, what is that error and what kind of error is it? Signal, the error was found in row. I'm going to put ln a row is and error go and then no line. Okay, so you might notice that we have it, I don't know what I did with the code. We have it the definition of the signal array. We also have some notes. Let me just look for them. Here we are. So before that we started to do this kind of videos, I think that the first video about the compile, we did an array in the top of this function, but actually we haven't used it in all through all these functions. So I'm suggesting to put it in the end, because it's not necessary to put it in the beginning if we are not using it. So else I know array, it's going to have 12 elements. Just write it down. Okay, success, that is never gonna happen. Close set brackets, reset, and invalid symbol, unexpected, end of file found, not enough tokens, not enough binary tokens, invalid order of operators, too many closed brackets in the proposition, mismatch brackets, in the special case of open bracket, reset, oops, same match brackets, and in this line is close brackets, reset, and the last one is over semicolons character. Okay, let's compile it to verify that everything is okay. Ooh. Typos. Okay, something related with Q. The book is kind of set out of the standard of C++, but it has the major advantage that we can just call it in this way without instances as we usually do with the set, and this part we're just going to input to send a message to the compile output, and that's enough for the client to check where is the error in its knowledge base. So guys, that's it. I hope you enjoy it. If you have any question in doubt, please remember, put in the comments if you have some details about the code. If you see I can improve this code, I suggest you to do something like that, or any advice, I'm open on it. This is the reason that I'm here. It means that I'm also doing these videos to improve the coding skills. So the next step of this video is to test all these functions and determine if it's going okay. After that we are able to move to the translations of the Infix syntax analyzer, I don't know, to a large amount of different languages, maybe Spanish, English, Russian, German, everything. And after that we are going to move to the main part of this project, that is the inference kernel. So that part is going to be very, very interesting, so wait for it. See you guys and enjoy.